I mentioned some of her accolades at the beginning of the presentation. I'll give you a little reminder here about Asha Saxena, who is with us. She is, again, best known for her work in artificial intelligence strategy, focusing on digital transformation as well, along with data governance. And as I mentioned earlier, she is the author of The AI Factor and an adjunct professor at Columbia University. And so far, we've heard in this conversation, about 25 minutes or so, a little bit about how IBM and SHI out there helping teams really try and integrate AI into the development pipeline. We've touched on some of the business value that they're starting to see now. We're really excited to explore more with you about what more we can expect and dive deeper and hear your insights. So with that, welcome, and let me turn things over to you.
Thank you, James. I'm Asha Saxena, and I'm so excited to be here to talk about something that I'm very passionate about. I get to present on AI topics all around the globe, but this one specifically, when you talk about AI in development pipeline or software engineering, I think this is something which I'm really interested in, because I think where the gap between AI promises and what organization actually experiences is the widest here. And today, I want to discuss how we close that gap. I've spent years of my career, professional journey at the intersection of enterprise AI strategy and real organizational change as a professor at Columbia University, as a founder of World Leaders in Data and AI, and as an author writing books about AI, where AI actually meets for human inside organization. And especially my last book, Digital Human Advantage, where I was fascinated about how agentic AI is going to change our workforce, having humans right next to digital humans and really collaborating. What I've seen really is the gap between what AI can do and what organizations are set up to receive is enormous. And software engineering is the place where the gap is both most visible and most costly. So I'm going to be talking about really this topic as a practitioner, what is happening inside engineering organization, what is working, what's failing, and what you specifically need to do about it. So as we get started, the very first question I want to talk about is what actually you're thinking about when you're thinking about your own organization in your engineering team. Where do you think the people on your team, the talent you're trying to compete or attract or retain, the humans who are supposed to be driving your digital strategy, how much of their time is actually spent on writing code? So think about it. Don't go with what you hope the answer is, but think about what you have actually observed. And here is what the research says: only 30%. This is from McKinsey report, which talks about only 30% of every dollar you spend on engineering talent is going towards what you hired engineers to do. What does that mean? That means that the other 70% is going on meetings, documentations, debugging, review cycles, or context switching or waiting. And that is not code. This is most important slide, I would say, in the whole conversation, because it reframes the entire AI opportunity. We are not talking about making developers just 10% faster at the 30% they're already doing. We are talking about transforming what happens to the other 70%. That is the real story. When they published this research, it quantified something that engineering leaders had felt for years. Look at the breakdown on the slide. 30% write is writing new code, but 20% in the code reviews and meeting. 19% of the time, the developers are spending on debugging, 12% on documentation, and 10% on context switching and waiting, 7% on everything else. So here's what is interesting about that 70%. Almost every single item on that list is addressable by GenAI. Not all of it, not perfectly, but meaningfully. AI can draft documentation, it can review code faster, more thoroughly than a human in the queue. It can help a developer step back into a code base they haven't touched in 3 weeks with full context in seconds rather than hours. I talk to a lot of engineers, and they get excited about the potential, but they're also scared. They're scared because when you look at this, the conversation about AI and developer productivity is not just the conversation about making the red bar longer. It's about transforming every gray bar on this chart. It's really about thinking, how do we really bring the productivity when we are working with the software engineering teams? This is the real opportunity, and that is what the rest of the session is going to be about, focusing on how do we really maximize on this opportunity. But before we go any deeper on I want to be honest about the environment we are working AI is walking into in our work environment, because it's not a clean slate. Let's talk about the technical debt first. Average enterprises carry about 29 million in technical debt per application, not per company, per application. Every new feature you try to ship has to fight its own way through the years of accumulated shortcuts and code that nobody fully understood anymore. Let's talk about legacy systems. 43% of banking system globally still run on COBOL. 60% of enterprise code runs on system over a decade old. These systems are not going away. They run payroll, they run process claims, they power core operations. And I think a lot of us who are in financial services understand that. And then comes the talent shortfall of about 1.4 million software engineer roles that are not fulfilled. The GitHub Octoverse report here that mentions that the developer demand is growing 3 times faster than supply. And speed versus quality. We have been asking engineering teams to ship faster for years, code that works in demo but breaks in production. I mean, this is a real problem in a lot of the engineering shops. Technical debt is accumulating faster than it is paid down, a cycle that compounds. And I would say these four forces are not independent, they interact. Talent scarcity meets legacy system, and you have no one who can read the old code. Technical debt meets the pressure to ship, and you get shortcuts on top of the shortcuts. AI doesn't erase these forces, but it fundamentally changes the economics of addressing them. And I think that's what we need to focus on. And I think a lot of these issues that I'm talking about, we know that it's not something that we are unfamiliar with. But I think really thinking about how AI is going to come and play the role. Let's look at $1.52 trillion. Again, $1.52 trillion. That is the estimated global burden of technical debt in enterprise software. Let me put it in context. That is larger than the GDP of Australia. It's larger than the market cap of every major bank combined. And it is sitting inside your systems right now. It's invisible, unaccounted for on any balance sheet, but felt every single quarter as slow delivery, higher incident rates, and rising cost. This research, it's interesting when you look at these research. Specifically, this research shows that developers globally spend 33% of the time dealing with technical debt, not feature work, or not innovation, not managing this consequences of decisions that, so this is the effect that is having on our technical team. The 5 bullets on the right side on the slide is what technical debt cost looks like in operating terms. Slower feature delivery, higher incident rates, harder hiring, more expensive to modernize, and compounding everything that I'm talking about here. Every day you don't address this, it keeps growing. Here's a critical insight, I would say on this slide for me. This is the first moment in history where we have a technology that can actually attack this problem at scale. AI can read legacy code it didn't write. It can generate documentation for systems that have none. Imagine the mainframe system, the COBOL, having that be modernized in modern language. For the first time, this 1.52 trillion number has credible path to reduction. And I think that's the hope when we think about what is the potential of AI in our development pipeline, in our software engineering lifecycle. I want to spend a moment here on what Gen AI or AI in general can do for engineering. Actually, it's not the mental models in the room, or how we map that. It's really thinking about what it is and what it is not. Some of you have had engineers who tried, Claude Code or GitHub Copilot and found it useful. And I would say some of you have read about AI generating entire applications, and you're skeptical. I mean, vibe coding has become really popular, and you know that now non-technical people can actually create these applications. But I've heard and had several conversations with engineers who would say that this cannot go in production. Some of you have concerns about IP and security, rightfully so, as your legal teams are raising questions. All of those experiences and concerns are valid. So, what it is really your co engineer. It's not a replacement engineer, it's not a simple autocomplete tool. It's modern AI coding system that can read your existing code base with context. They can understand a 10-year-old function and explain what it does. They can generate code that follows your patterns and conventions. And increasingly, they are moving from answering question to take action. And that's what my whole book and my book, which I wrote, Digital Human Advantage, is about. It's about agentic system that can plan, execute, and iterate. But remember, what it is not is infallible. This is critical because AI hallucination is real. Confidentiality, fluency, AI can act as if they're really confident. They can act as if they're really sure about even a wrong answer. There are stories after stories about how AI is hallucinating in healthcare, when they come up with diagnosis, or in legal, when the attorneys are looking at the cases and the cases are not even real, and AI is coming up with stories. So really thinking about what AI can do and what AI cannot do is really, really important. We have to remember a strategy is not same as tool. Some organization I know treat AI deployment as a tool purchase. So this is really important to remember, is that yes, AI is a powerful tool, but it's just not a tool. But a lot of organization, and I've been in the room where senior leadership will talk about how AI is they're just deploying AI as a technology, or a tool that they purchase. They're the ones who are actually going to be disappointed because they will not be able to identify the business value or the outcome the board is going to be looking at or their stakeholder will be looking at. The ones that treat it as a workflow redesign with governance, training, and measurement baked into the system are the ones that's going to win. And I'm going to talk about governance because I think that is important as I continue our discussion. And before I do that, I want to talk about this slide. And this is not a roadmap slide. I know you can get confused with that, but it's truly about the current state slide. Every stage is highlighted in red. That is mature, production deployed AI capability, operating inside enterprise organization right now. Let me walk through the ones that matter the most. So let's talk about the first one, which is coding. That I think is the obvious one. AI tools are generating, completing and refactoring code at scale. That is true, and we all have seen that in organization. But I think testing is an important one. Testing is where the efficiency gains are often underappreciated. Manual testing, writing, one of the most time-consuming part of the development process. AI can generate test cases from code, identify coverage gaps, and run regression suites continuously, which I think is a place or opportunity for organization to really spend time and money in. Code review is where AI is creating step change in quality. Facebook's engineering team uses AI to pre-screen code before human reviews it and catching estimated about 70% of common bugs category automatically. That means human reviewers spend their time on logic, architecture, security, not formatting and style. And modernization, which is one of the most relevant to 1.52 trillion problem that we spoke about before. IBM has used AI internally to translate millions of lines of mainframe code to cloud native architecture. The time saving are not incremental, they are transformational. And that's where transformation comes in hand. This is not the future. This is today. I'm talking about the current state. The question is not whether AI is in the pipeline. It is whether your pipeline is ready to use it well. In my book, The AI Factor, I introduced Power Quadrant as a strategic lens for enterprise AI adoption. And I think having frameworks truly help organization to figure out how to deploy. I want to apply it specifically to software engineering because I think it clarifies a choice that most organizations haven't made consciously. Most companies are using AI in engineering today. Uh, and I would say that sits in the optimizer quadrant. They're using code completion to write faster, they're using AI review tools to catch bugs sooner, but they haven't fundamentally changed how engineering works. They have just made the existing workflow just incrementally better. And I think that's okay. It's okay to be in any of the quadrant as long as you're seeing the benefit. And extenders are the organization that are using AI to do things at scale that no human team could do manually. Imagine running code reviews across every single request in every repository simultaneously with consistent standards. That is not a 55% productivity gain. That is a different category of engineering capability. I think that's what organizations need to see, that where are they using. And I agree with a lot of the organizations I speak with, where the CIOs are talking to me and saying, it's a challenge to get the software engineering team moving in that direction, even though you would think that they would be the one jumping on the bandwagon faster than anybody else. So understanding where your organization is sitting on the power quadrant becomes really helpful. I want to go to the next quadrant, which is innovator. Innovators are using AI to build new products, revenue streams that would not exist without it. Companies building AI native SaaS products, where the software learns, adapts, and personalizes in real time. Multiplier. Okay, now this is the one which I think most innovative companies are thinking about. Multiplier are the rare organization where AI has become so embedded in the engineering function that it has changed the business model itself. And I've actually worked with few companies who actually have used this as a complete an example or a base to change how they serve their customers. We are seeing early examples in financial services and healthcare. Software that writes portions of itself based on the real-time market data or clinical data. And I would say that here is a strategic question for you. I want you to sit with it. Most organizations start as an optimizer by default. That's the easiest way to get started. But where do you want to be in 24 months? And what choices do you need to make now to get there? I think that's a big question, is really thinking about where do you want to be and how do you plan to get there? Because those choices are different depending upon where your target quadrant is. So I want to tell you a story because I truly believe that sometimes listening to a story can put things in perspective. A large organization that I work with, the global financial institution, one of the largest in the region, had a core system that had been running for about 40 years. It was written in COBOL, absolutely mission critical. It processed millions of transactions every day, and it was understood by exactly 3 engineers. And this is a true story. And I tell you that the 2 of the engineers retired, and we got a call. The organization had made a decision they needed to modernize the system, migrate it to a cloud native architecture. They estimated about it'll take 18 months. They assembled a team, they brought consultants, they spent $14 million. And after 18 months, they had partial documentation, a partial understanding of the system logic, and modernization project was nowhere close to completing. And then they called and they said, we want to try AI assisted modernization. 6 weeks later, same scope. Now, I want to be honest with you, 6 weeks is not a median outcome. It is an exceptional one, achieved with the right tooling, the right team, and the system that had enough structure for AI to read. But here is what is, I would say, is a representation here. AI did not make the modernization 10% faster. So remember that. It did not save a few $1,000s, a few thousand hours. It changed the problem from we may never be able to do this to we did it in 6 weeks. This is not a productivity gain. This is the different category of possibility. And that is the shift I want you to internalize as you think about what AI means for your organization, because it truly can be a game changer if applied to the right project with the right team, with the right leadership. So I've been talking about productivity. So I want to give you some hard numbers as we talk about productivity. So when we look at the productivity data on this slide, 55% faster task completion for AI assisted developer versus control group. That is from McKinsey study, 1,500 enterprise developer across the industry. So this is something that they have studied and they've done the research, and these are the numbers. That's where it's coming from. This was not a startup sample. This was a large enterprise with complex code base. 2 times more pull requests merge per week. And this was from GitHub's Copilot research across enterprise customers. Not 10% more, not 20% more, 2 times. 40% reduction in context switching time, another research report which said context switching is one of the most expensive hidden costs in engineering. Every time a developer has to switch tasks, research shows that it takes about 20 to 30 minutes to fully re-engage. AI reduces that cognitive overload of picking up and where you left off. And 85% of developers reporting that AI improved their code quality. But here's what these four stats don't capture, and what I think the most important inside the session of this session is the compounding effect. Faster code generation means faster feedback cycles. Faster feedback cycle means better design decisions. Better design means less technical debt. Less technical debt means even faster future development. Organizations that start this cycle now are not 55% ahead of those who wait. They are building a compounding trajectory advantage that gets harder to close every quarter. The cost of waiting is not neutral, it is negative, and it's accelerating. So I really want you to pause here and think about this, because we do get in this downward spiral of thinking why we should not. But if you really think about, if you don't, the cost is much, much higher. All right, so I want to shift the conversation for a moment from productivity to talent, because talent is an important conversation. 74% of the developers say they would choose an AI-enabled workplace over a higher-paying non-AI one. Nearly 3 in 4 engineers will take less money to work somewhere that gives them better tools. And why is that? Because they know that they'll be more productive. There's much more worker satisfaction. In market where the average time to hire for senior software engineer is about 45 to 60 days, and where composition for top engineers has escalated to levels that strains every large organization's budget. And I think it's very it's a known fact in the market. Developer experience has become the competitive weapon for organizations. So look at the right side of the slide. This is not theory. Organizations like Google, Spotify, many more other organizations have published internal data showing exactly this pattern. AI removes the friction, engineers focus higher, satisfaction rises, top talent stays, and innovation flywheel accelerate. The question is not whether this cycle exists. The question is whether your organization has started it or not. And the question everyone is asking, and we can add, this is like the elephant in the room: will AI replace developers? And developers are asking this question. I understand why the question gets asked. When you see AI generating code, writing, tests, reviewing pull requests, modernizing legacy, the natural human reaction is to ask, where does that leave the humans? But I want to propose a different question, because I think the replacement question is the wrong frame. And not just because it's pessimistic, I think it's the wrong question because it focuses on the wrong unit of analysis. It focuses on the task when it should be focusing on the person. In my book, I talk about that. Digital Human Advantage. I make this argument that the organization that win in the age of AI are not those who automate the most tasks, uh, just for the workforce. They're those who design the most powerful version of what their humans become. It's not about the task, it's about the human. So the right question would be, what does your best engineers become when AI is handling the work beneath them? And so that's the question to ask. When AI handles the boilerplate, the routine debugging, the formatting, the documentation, your senior engineer is free to do AI what AI cannot do. So understand the business context, ask the right architecture question, make the ethical judgment call is what the humans need to do. Build a relationship with the product team that turns into ambiguous requirements into a right decision. Those are the real challenges. And this is not a small role. This is the most powerful one. And the organization that designed that elevation, not as a byproduct, but intentionally, are the ones that will have the best engineers, the best production, best products, the strongest competitive position in the market. Now we get to talk about what leaders must get right. Everything I've shared so far, the data, the framework, the stories, that is the opportunity side of the ledger. But I have spent enough time inside real enterprises deploying projects to know something that the vendor presentation won't tell you. The technology is the easy part. because of course every vendor comes and talk about technology, but really the important part is that the organization with unlimited AI budgets still can fail. They fail because I've seen organizations with a modest tool investment achieve remarkable results when large budgets doesn't succeed. The difference was almost never the technology. It was leadership. So for the next session, I want to focus on the decisions you need to make, not the tool you need to buy. The tool is not the strategy. If your AI strategy is a list of tools you have or you want to buy, you don't have the AI strategy. You have a procurement list. I watched this pattern repeat dozens of times. An organization that hears about AI coding tools, vendor demos, budget approval, and deploys engineers. And then 6 months later, the CTO or CIO is asking why the impact isn't showing up in the delivery metrics. The answer is almost always on the mistake side of the slide. The tools got bottled onto a broken workflow. Nobody redesigns the engineering process around AI. They just added AI into the existing process and hoped for the improvement. Or governance wasn't built before deployment, and I talked about governance earlier because governance has to be from the very beginning. And the first security incident creates a complete freeze on AI usage. That's not a great start. Or engineers were told to use AI but never trained on how. They used it badly or poorly and got burned by hallucination and quietly stopped using AI. The strategy side is different. It starts with a question: what specific problem are you solving now, not what we want to be, or what we want to be productive in. It's not about just productivity, it's about the problem you're solving. It's not the hope, it's the use case. A use case is: we want to cut our legacy modernization backlog by 40% in 18 months using AI assist code translation with quality measured by defect rate and the test coverage. So it has to be measured outcome. That is strategy. Everything else follows from the level of specificity. Okay, so let me talk about governance because I know that that word makes some people in engineering organization nervous. It sounds like slowing down. It sounds like committees that's going to put roadblocks. It sounds like opposite of innovation. I've heard a lot of engineering teams saying governance, we're going to talk about governance, that means we're going to slow down. We cannot innovate because the governance is, the killer of innovation. Here's what governance actually is: it's the difference between AI that you can scale confidently and AI that you have to shut down after an incident. We spoke about the security incident. So let me give you some real example of what these risks look like in practice. IP risk. In 2023, when Gen AI was becoming a lot more popular, Samsung engineers accidentally leaked sensitive proprietary source code by pasting into ChatGPT. The code was used to train future versions of the model. Samsung had to ban using Gen AI tools on company devices then. So that is a bad governance policy because it actually was after the effect. Same thing with security. Security, if you don't have security originally, the vulnerability that are not exposed early on can cause detrust into your teams. Hallucination, the same thing. When you're thinking about AI can generate code that looks like right or it is confident with the wrong answers, it's a problem. The organization that are scaling AI successfully are not the ones that are eliminating governance. They're the ones that are building it into the workflow from the day one. And I've seen personally these organizations do well because they are thinking about governance from the very start. It's not just committees, it's not just the tools, it's having the right leadership who knows when to incorporate the governance policies into not just the paperwork and policy document, but actually inputting into the system organization with the right tools. So, as you think about what platform or tooling you need to operationalize everything we have discussed so far, I want to give you 5 capability questions that should drive every evolution conversation you have. The first context: can the system understand your existing code base? And that's important. Not just generate new code, but understand. This is critical distinction. A tool that can write Python from scratch is very different from a tool that can read your 10-year-old microservices architecture. Understand the patterns and convention. Generate a code that fits. So really think about the context-aware AI. The second is modernization at scale. Greenfield is easy problem. The hard problem is the 1.52 trillion problem is the legacy. Can the platform support the documentation, translation, and refactoring of legacy code at the enterprise scale? The third is the enterprise governance. Is the system auditable? Is your IP protected? Is it compliant with your data classification requirement? Can you operate within the security parameters? So that's really important. The fourth is the workflow integration. The best AI tool that doesn't integrate with your existing IDE, your source control, your pipeline is going to add friction rather than removing it. Integration is a deployment requirement, not too nice to have. And then the fifth is the business outcome measurement. Can the platform tell you its impact not just on developer throughput, but on actual delivery performance and cost? Without that, you're running a anecdote. So ask these 5 questions. The answer will tell you everything you need to know about whether the platform is built for enterprise or for demo. And that's the challenge when you work with AI, to make sure that you actually can scale. I will spend few minutes on what's coming, not a science fiction, but a strategic planning input. 24 to 36 months from now, the term AI coding assistant will feel as dated. And I think it's already getting dated. Like how it was mobile website. It's not about coding assist anymore, because we all have agentic AI right here in our world now. The shift is already under the way from manual to assisted and assisted to agentic. Agentic coding system are already in early deployment at organization, including Cognition AI with their Devin system, and inside GitHub Copilot. There are already systems that are available. These are not tools that respond to prompt. They're the systems that are ready to go out and provide breakdown of the subtask, write code across multiple files, run tests. And I think now that we are moving from just code assist to agentic AI, we are now entering the world where self-healing system, code that monitors its own production behavior, detect anomalies, propose or applies fixes are also coming in operations. This is not just AI writing code, this is AI in maintaining system. Then we have AI architects, system that can evaluate architecture trade-offs and propose design alternative. And those are now in place. So these are the evolution that is happening, and we are now in the world where cross repository intelligence is available, that AI that understands your entire enterprise code base as a single context, not just one file at a time. So these are the strategic implication, the governance infrastructure, the culture of human and AI collaboration, the measurement framework, everything we have discussed today. These are the foundation you need to operate safely in the agentic world, because we are living in the world of agents. Organizations that build the foundation now will be ready. Organizations that don't face a choice between moving fast and dangerously being slow, or just watching from the sideline, are the ones who are going to be stuck. So as we think about being ready, I know a lot of the organization or the teams could be hesitant, but the cost of being hesitant becomes really, really strong and powerful. So I want to close this section of this keynote by talking about where we are, because the shift from AI as assistant to AI as agent is not a roadmap item. It's happening now. The Cognition AI launched Devin, described as a fully autonomous software engineer. In its demonstration, Devin took a natural language task description, planned the implementation, set up the development environment, wrote code across multiple files, debugged its own errors, and completed the task with no human intervention. Where Devin's real world performance matches the demonstration is still being evaluated, but it's demonstrated that agentic coding is technically possible today. Now, we can absolutely challenge the output, because I work with some really, really strong engineers, and of course, they challenge the AI output many, many times. And I completely get that. But I think when we talk about the assist, we cannot deny the value of AI assist. And the agentic AI is in development. We can use that as assist. We can use that to at least get our work, the manual work, done. And I think what it truly means strategically for us as organization is that is, as I wrote in my book, The Digital Human Advantage, is about the shift from AI as a tool to something that we pick up and put down, which is to an AI as an agent, something that acts on the behalf of the world. This shift changes the governance model, it changes the review model, it changes the workflow model entirely. The organization that have built the governance infrastructure, the culture of human AI collaboration, because I think that's a very important shift of how human and digital collaborate for the advantage. And that's what I talk about in my book, is the digital human advantage. It is really important that collaboration is measured. The measurement frames we have discussed today, that I think is important to understand how the transition happens from human to human, from to human working with agents. This whole shift from task to capacity, not just focusing on the task, because task can be done by agents, but what is the outcome you're looking for? The ones that haven't, and I think this is the most important foundation that you build now, is not just for today, with the tools you're using, but it's about tomorrow, the agents you'll be working with. And I think it is important to remember that the journey you've started, and if you have not started, or if you have started, is important that you take that journey, because this is the journey we are on already. I want to close with the line on the slide, because I think it is the truest thing I can say about this moment, technology and leadership. The future of software engineering belongs to the leaders who design it, not those who wait for it. You were here today, you're engaged with this material. This is the beginning. What happens next day, the use cases you name, the governance question you asked, the metrics baseline you set, that is the work you have to do. I'm available for questions. You can find me on LinkedIn, Asha